So this video, we're going to go over the Wi-Fi Fern. It is a wireless assessment tool that extends on the capabilities of AirMon, AeroDump, and Arp Replay. Plus, it's a nice graphical user interface for those who aren't quite comfortable with command line and don't have all the syntax memorized. Another nice feature is that for every key that you crack with Wi-Fi Fern, it is automatically saved in a database for future reference. The database keeps track of SSID, MAC address, encryption type, and channel associated with each cracked key. At the bottom left of the window, it tells you the version of Python and AirCrack it's currently leveraging. To begin, we start with selecting the wireless interface that we're going to be putting in the monitor mode. This is the same as when you use AirMon NG, the interface name, and then start. So here, let's select the WLAN 0 interface. You'll see here that monitor mode is enabled on a new interface called WLAN 0 Mon. Automatically, it starts discovering access points in the area. It separates out the ones that are encrypted using WEP or WEP and WPA. The WEP section has attacks specialized for WEP, whereas the WPA section is designed to run dictionary attacks against a captured four-way handshake. Let's look at WEP first. Here you see the access points that are encrypted using WEP. You can connect to each access point in the GUI. You'll see the SSIDs, the MAC addresses or BSSID, the channel it's operating on, the power level. And remember, the closer this number is to 0, the stronger the signal. The WEP encryption, and if it supports WPS. If the access point supports WPS, this will be highlighted yellow and we can attack it directly. Since none of these support WPS, let's look at the regular WEP attacks. Arp Replay has these 6 distinct attacks to break WEP encryption. Arp Request Replay is the most effective way to generate new initialization vectors, or IVs. The program listens for ARP packets, then retransmits it back to the access point. Okay, so there are 2 things to define here. Arp and Initialization Vector, or IV. ARP is an acronym for Address Resolution Protocol, a network protocol used to associate an IP address to a MAC address. A host wishing to find the MAC address broadcasts an ARP request on the network. The host on the network that has the address in the request then replies with its MAC address. The initialization vector, IV, is an arbitrary number that can be used along with a secret key for data encryption. The inherent weakness in WEP's implementation makes it possible that if an attacker were to collect enough IVs, they would be able to derive the secret key for the encryption. Now back to Wi-Fi Fern. In the Arp Replay Attack, we send the access point a flood of ARP requests. This causes the access point to repeat the ARP packet with a new IV. The program retransmits the same ARP packet over and over again. However, each ARP packet repeated by the access point has a new IV. It is all these new IVs that allow you to determine what the WEP key is. The chop attack attempts to decrypt packets without knowing the key. It works by taking away parts of the network packet, then attempting to guess its value. The attacker then sends a packet to the access point, and if it's accepted, the attacker knows that the correct value has been guessed. It is a replay attack where the attacker can eavesdrop on traffic, modify it, and inject it back into the stream. The fragmentation attack works by an attacker capturing some wireless traffic. The traffic then is modified and cut into smaller chunks and sent to the access point. The access point gathers those smaller chunks and reassembles them into a single packet. That packet is then sent on the network with the initialization vector appended to it. An attacker repeats this process until it has enough initialization vectors to decrypt the traffic. The Herte and the Cafe Latte attacks are attacks against the client, not the access point. This attack exploits the fact that in WEP, the client has to prove that it knows the key, but the access point never has to prove itself. So the attacker can force a client to send requests to authenticate over and over again until the attacker has gathered enough information to crack the key. The Cafe Latte attack uses ARP packets, while the Herte extends this to IP packets as well. P0841, or the Interactive Packet Replay Attack, is an attack against the access point that may not have any clients associated with it. The attack replays traffic that was previously captured and replayed against the access point to gather the initialization vectors. So for this example, we're going to go with the Arp Request Replay Attack. When you launch an attack, the process it's on will highlight yellow. When you see the progress bar start to move, don't fret if you don't have a key even though it's green and seems like it's finished. It often takes capturing many more initialization vectors before it'll tell you it's cracked the key. The cracked key is then put automatically into the database. Okay, now let's go down to the WPA section. Here again, you'll see the network names, MAC addresses, power, channel, and encryption. For the WPA, the only attack option is to brute force. So here, we'll select the dictionary that you want to use to conduct the attack. Once again, I'm going to use the Netgear word list as I see Netgears in the access points. But you also have the option to brute force the WPS enabled access point. WPS stands for Wi-Fi Protected Setup. It's a convenience feature that allows the user to configure a client device to use a wireless network by simultaneously pressing a button on the access point in the client device. The devices trade information and then set up a secure WPA link. The link is established by the client entering an 8-digit PIN number. An attacker can just attempt to try all the combinations of numbers until the correct one is found.